Hello dear student, welcome back DHU Lab. Today in this video, we will discuss MCQ practice series of controller part number 14. Before starting this video, if you not subscribed our channel DHU Labs, I request you please subscribe it. I also request you please like and share it. For more information, you can also visit our website dhulabs.in. Question number 1. The figure shown below represent blank controller, or you can say blank analog controller. Option A, PI proportional integral. Option B, PID proportional integral and derivative. Option C, PD, that is a proportional derivative. Option D, proportional. The answer is option number C, that is a PD, that is a proportional derivative. See, as shown in the figure, at the inverting terminal of the op-amp, the voltage supply is given through the parallel circuit of the R1 and C1, and there is a feedback R2 resistor is used. The positive terminal of the op-amp is connected to the ground. So, when you solve this equation, you receive two terms. First term is a proportional term and second term is a derivative term. So, when you combine these two, okay, so it's look like the PD controller, okay. So, it is a call, the output is called PD, proportional derivative. Question number 2. The figure shown below represent blank controller or analog controller. Option A, proportional integral. Option B, integral. Option C, practical integral. Option D, practical PI. The answer is option number C, that is a practical integral. See, as shown in the figure, the error in form of the voltage is applied to the inverting terminal of the op-amp through the resistor R1, and in the feedback side there is a RF resistor and capacitor is used, and second hand side, that is at the positive terminal of the op-amp is connected to the ground. See, when we not use any feedback resistor RF across the capacitor, the circuit is look like integral. But when the frequency, when you apply the DC signal, the DC signal most probably have the zero frequency. So after charging condition, full charging condition, okay, the capacitor behave like open circuit, okay. So capacitor is like open circuit. So at that moment, the op-amp is work like open circuit. So in open loop case, we know that the op-amp have the operational amplifier have infinite gain. So we found here the output is going on the saturation limit. The whatever supply voltage V plus VCC and minus VCC is given to the op-amp. So output is going on the saturation limit if you are not using the RF, which is parallel to capacitor. So when you are putting this RF across the capacitor, and when the frequency or when the capacitor is fully charged, and when you apply the DC pulse, the gain of that op-amp is become like minus RF upon R1. So it is a finite gain, that is a finite gain. So finally, this circuit is called practical integral circuit due to that. Question number 3. The figure shown below represent blank analog controller. Option A, derivative. Option B, integral. Option C, practical I. Option D, practical D. The output is option number D, that is a practical D. See, as shown in the figure, the voltage error is applied to the negative terminal of the op-amp through the two components, that is a resistor and capacitor. They are connected in series. Similar to as a feedback point of view, there is a RF and C2 are connected in parallel. When you solve this equation, the equation is look like the derivative. So here this figure is nothing but it is a practical derivative. Question number 4. The figure shown below represent blank analog controller. Option A, on off. Option B, integral. Option C, proportional. Option D, none of this. The answer is option number A, that is a on-off controller. See, as shown in the figure, the open loop amplifier is coming here. There is no feedback element is present. The amplifier have plus VCC and minus VEE supply voltage, and V in and V reference both input voltage is given to the inverting and non-inverting terminal respectively. Output is a V out. So this equation, this value, this output equation is open loop configuration. So it only provide the two position, high value and low value, that is a positive saturation and negative saturation. So it have only two value, that is a two positions. So it is look like on off controller. Question number 5. The integral controller, the integral gain Ki is expressed in option A, percentage change per minute per percentage error. Option B, minute per percentage error per percentage change. Option C, minute per percentage change. Option D, percentage per second. The answer is option number A, that is a percentage change per minute per percentage error. Question number 6. In integral controller, the output is expressed in option A, percentage per minute per percentage error. Option B, minute per percentage error per percentage change. Option C, minute per percentage per change. Option D, percentage per second. Question number 7. In proportional controller, the output is expressed in option A, percentage. Option B, percentage error per percentage change. Option C, minute per change. Option C, minute per percentage change. Option D, percentage per second. The answer is option number A, that is a percentage. In proportional controller, the proportional gain Kp is expressed in option A percentage per percentage error, option B percentage controller output per percentage change, option C percentage controller output per percentage error, option D percentage per second. The answer is option number C, that is a percentage controller output per percentage error. Question number 9. Integral controller offer blank response at higher integral time Ti. Option A fast, option B constant, option C sluggish, option D none of this. The answer is option number C, that is a sluggish. Question number 10. Integral controller offers blank response at the higher integral gain Ki. Option A fast, option B constant, option C sluggish, option D none of this. The answer is option number A, that is a fast. Hope you receive very good information from this video. Please like that and subscribe our channel D as Labs. Thank you very much for watching.